Welcome to the video on the basic electrical engineering, and in this video we discuss the node analysis. In the first video we talked about the node analysis is nothing but it's an analysis based on the Kirchhoff's current law, and there is another way of solving the network is the mesh analysis, and mesh analysis depends on Kirchhoff's voltage law. We have taken this example and we try to understand that how much nodes we will take so that we can successfully solve the network. And then finally we come to the conclusion that if we take one node like this, another node here, and in this example one more node over here. So by taking the number of nodes as 1, 2 and 3, we can easily solve this network. What does it mean? That we can find the current through any of the element or any voltage across any other element, so we can easily find. And the potential of this node 1, let us say V1, and node 2 is V2, and this node 3, instead of writing V3, we can say that this is grounded, and this is grounded means we can use a circle over here to denote this is a node, and we can say this is connected to the ground, and this is having this is a voltage that V reference is equal to 0. Then we can write the equations for all the by using the KCL and Ohm's law. We can write the equation for all the nodes. So if there are 2 nodes and 3 nodes are there, one is a reference. So how many equations will be there? There will be 2 equations, one for node 1, another for node 2. Like that we have solved it, and the logic that we have used is that if I am using the node 1 and trying to calculate the equation for node 1, assume that all the currents are going out of the node. Like this, let us say I1, I2 and I3, all the currents are going out of the node. So what is the easy thing is that you just need to add I1 plus I2 plus I3 is equals to 0. You need not do any worry about the sign over anywhere. Simply you need to think one thing, that all the currents are going out of the node 1. Similarly, when you write the equation for node 2, you just simply think that all the current is going out of the node. Let us say I4, I5 and I6. So here also you simply have to add all the 3 currents. I4, I5 and I6 is equal to 0. You need not do anything, just to simply add these current. Some of the books, they have referred that writing these 2 current in opposite direction, but they have preferred one direction of the current. That is also right. Instead of having for node 1 and node 2 different symbol here, I3 is moving from 1 to 2 and I4 is going from 2 to 1. This is for our convenience, that if we assume like this, so we are just adding all the currents. We need not to worry about how to write. So, but if there is only one direction of the current, that is also true, but equation will change. So we will not go for that. Rather we can continue with the assumption that we have taken. So I1 is what? V1 minus of Vx minus of V reference. So V reference is already at a 0 potential. So the V reference is already at a 0 potential. So we need not to subtract 0 again. So V1 minus Vx minus 0. So instead of not writing the minus again, we are writing V1 minus Vx divided by R1. That is correct. Again we write V1 minus of Vy divided by R4. And another one is V1 minus of V2 divided by R2. I am not worried about the current. This is not required to write in the equations or in the network. Simply if you are in 1, so you just take 1 minus Vx divided by R1, V1 minus Vy divided by R4, V1 minus of V2 divided by R2. So one equation is done. Another equation is done if you have V2 minus V1. So when we're writing for 2, so you take 2 as a like priority, 2 as a higher potential, V2 minus V1 divided by R2, V2 by R5, and in this circuit, instead of writing V2 by R3, we will not write because there is a current source, there is not a voltage source that we can subtract. So if a current source is there, it is assumed that in this wire only the current I is flowing. So we simply need to say minus of I because our assumption is current is going out of the node and it is coming to the node. That is why we will write here minus of I. So we will have another equation done like this. So this is what we have learned so far using the previous video. And then what is the conclusion of the node analysis we get is that select one node as a reference node, fine, analyze, assign voltage to the remaining n minus node, that is fine, V1, V2, Vn minus 1. So in the previous example we have 3 nodes, 1 and 2 we have assigned the voltage and this one we have taken as a reference. So we have only V1 and V2. The voltage are referenced with respect to the reference node. So these voltages are nothing but with reference to the reference node. Since the reference node is having a 0 potential, so if we are writing V1, it is nothing but V10 actually, and this is V20, or somebody write this as V2 reference. So instead of writing all those nomenclature, if we simply write V1 and V2, it means that these are with respect to the reference node. Alright. Then apply KCL to each of the n-1 reference non-reference nodes. So one is the reference and you apply the KCL at node 1 and KCL at node 2. Express the branch current in terms of node voltage. So express the branch current. So branch, whatever the branches are coming out of it, express the branch current in terms of the node voltages. So यहाँ पर जब हम लिखते थे, we are writing V1 minus if there is nothing, so V1 minus Vx. So we need to write the current in terms of the voltages by using Ohm's law. So what is Ohm's law? V is proportional to I, or V is equal to Ri. From this V is equal to Ri, so we can find I is equal to V by R. So like that we need to find the current. Solve the simultaneous equation to obtain the unknown node voltage. So our objective is to find the node voltage 1 and node voltage 2. So like that we need to find the node voltage 1 and 2. So let us take an example and try to solve that. In this example, can we solve it and find out that how to solve this equation. So let us try to solve this equation. So here let us choose that in this problem we have 2 nodes are there, so many nodes. So let us choose one of the node here and say it 1 and another node over here, and let us say this is 2. And V1 is obviously the node voltage is V1 and V2 is obviously the node voltage is V2. It's okay, V2. And another node we will choose and we will just make it as a reference node, and the potential over here is 0 because this node is a resemblance of the node over all these 3 elements. So we can take the reference any one of the 3, but other 2 we need to mark as 1 and 2 and write 1 and 2. So if we need to write equation for node 1, so using KCL and Ohm's law, we will need to write equation for node 1. So sorry, in node 1 what do you see that how many branches are connected? So here we have 1, this is 2 and this is 3. 3 branches are connected with node 1. So we can say that this is node 1, this is of like say 1 and this is 2 and this is 3. So 3 currents are there that is connected. So we can say I1, I2, I3, but need not to write all those things again and again. So let us write the equation for this branch 1 first. And here it is V1 is directly connected with the this reference. So we can write V1 divided by V1 minus 0 divided by, what is the resistance in this network? 4. So this is like this. So another branch is there where V1 is connected with V2. So there is a node here which is having a potential. So I need to write again plus, because I'm not here to worry about the sign convention now. So here I will write V1 minus V2 divided by 8. Next, in this wire, because the current is already given 2.5 amperes, so this current is obviously, but we have assumed the current is going out from 1 and going to 2. But the current in the question is given 2.5 amperes in. So instead of writing plus here, we will write minus 2.5 is equal to 0. So our equation, first equation for node 1 is done. So how to solve it? First take the value of V1 and choose its all coefficients. So here it is 1 by 4 and then here it is 1 by 8. 1 by 8. So this is V1 by 4, V1 by 8. Another is V2 term. So there's a minus sign over here, V2, and the coefficient is 1 by 8. And this 25 will go to this side, other side, and it is 2.5. 2.5 will go to the other side, becomes 2.5. So if we can solve these two equations, then if I solve it, it becomes 3V1 by 8 minus V2 by 8 is equals to 2.5, and that equals to 3V1 minus V2 is equals to 8 into 2.5, that is 20. So finally what I get is one equation is ready. So finally we have got one equation that is ready, and now we will go to the another equation. Another equation means we will try to solve the node 2 here. Node 1 we have already solved, and for node 2 the potential is V2, and this is what is reference for node 2. So equation for node 2 using KCL and Ohm's law. So we are using here Ohm's law and KCL and solving this. So how many branches are connected? First you find us 1, 2, 3, 4. So there will be 4 additions. We came to know that there are 4 branches, means 4 out is there. So 4 current. Let us begin with 1. So to begin with 1, what we can write is V2, and it is going to V1. It is not reaching to reference, it is going to V1. So V2 minus V1 divided by 8. For 2, V2, and it is going to reference. So reference is of 0 potential, so just plus, and V2 by 12. The third one is we need to find the current over here, because the current is already given, which is into the node, so it is minus of 5. Another one from V2, the current is going out of the node, it is out means it is plus. So we are assuming that all the currents from the node, all the currents are going out. So whichever is going out, that is plus, and whichever is coming in, that is minus, and this equals to 0. So if I try to solve it, first take out the coefficient of V1. So obviously the minus is there, so minus of V1 by 8. Then you take out the coefficient of V2. V2, this is 1 by 8 plus 1 by 12. And then you solve this. This is minus of 2.5. It will go here, it will becomes 2.5. So it will becomes 2.5 again. So this one we can solve. This is minus V1 by 8 plus this will be equals to 5 V2 by 24. The LCM of 12 and 8, 24. And then this is equals to 2.5, and this we can write finally as we need to multiply here 3 and 3. So it will becomes minus of 3V1 plus of 5V2 is equals to 60, because 24 into 2.5 equals 60. So we get the second equation done. So like that. So like that we have got our second equations done, and now we can write down these two equations like this. So these two equations are done. Now we need to solve this equation. This is a simple x and y equations. We need to solve it. So there are different methods of solving it. One method is simplify, just eliminate the v1 from this equation. So if I take this equation, this equation is very simple. So this is 3v, and just add this first equation and the second equation, so these two will cancel out. Here it is 4v2, and this will equals to addition of this is 80. From this we can solve the v2 is equals to 20, and substitute the value of v2 in this equation 1. So it is 3v1 minus of 20 is equals to 20. So v1 is equals to 40 by 3, that is equals to 13.33 volts. So we get the value of v2 here, and we get the value of v1 here. So once you know the v2 is, so v2 you have got 20 volts, and v1 you have got 13.33 volts. So like that you can you get the solution of this v1 and v2. But if this network would have been a little bit of values are difficult, and suppose you have got 3 variables and you need to have this type of elimination of v1 and v2, then this would create a problem for you. So rather than that, can we have some other way of solving it? Yeah, Kammer's rule is one method. Convert this into a matrix. So if I convert that into matrix, I have to write down this thing in this way, where I will write the coefficients, first the variables over here, v1 and v2. So 3 is multiplied with v1, so write 3. Here is minus 1 is multiplied with v2, so minus 1. Here it is minus 3, and here it is 5. This side the constants are 20, and the constant is 60. So you have got this matrix equation. You need to find v1 and v2. So how to do it? So let us say this is a, and this is a variable that is x, and that is a constant that is c. So here if you just multiply a inverse ax, and here also you will multiply a inverse c, so you can just these two can come out to be 1, and you can get x is equal to a inverse c. That means you need to find the value of a inverse. So what is the value of a? A is nothing but 3 minus 1 minus 3 and 5. This is the value of a. So how to find a inverse? So a inverse, you can mathematics, you can go and learn that how to find the inverse of this matrix. I will give you this easy formula that you need to find. So to find the inverse, sorry. You just need to to find the inverse of 2 into 2 matrix. Just interchange these values on this matrix. So you just say 5 over here and 3, and these two you just change the sign of them. Let it be there at the same place. 1, it is minus 1, so you make it 1. This is minus 3, so make it let it be 3. The sign convention. And what is del? Del is nothing but del is a determinant. Determinant of the matrix is 3 into 5, that is 15, minus 1 into minus 1 into minus 1, that is 3. This is nothing but 12. So we can write here a inverse value is 1 by 12, this into 5, 3, 1, 3. So this is the value of a inverse. So what is x? X is equals to 1 by 12. The value of a inverse we are writing, and then we multiply with the c. C is 20 and 60. So here you just multiply, just keep this 1 by 12 as it is, 5, 20 and 1 and 6. So this comes around to be 160 here. Similarly, you can 3 into 20, 3 into 60, this comes around to be 240, and then you can simply write down this value as 13.33 and this value as 20. So see, the value of x is what? So finally what you get is here that v1 and v2, this matrix output is 13.33 and this is 20. So that is how you can find now easily, like V1 and V2 is equal to this value. So simply this looks tedious, but in the practice, suppose these values are different and difficult to solve, then this Cramer's rule will be very helpful. For 2 into 2 matrix, it is very easy to find out the inverse. Just you need to swap this 3 to here and 5 on top. So 5 and 3 will just interchange its place, and this side will be having like 1 and 3. There is only on this will change the sign, and like that you can just simply find the del, and you can find the value of x unknown variable, that is v1 v2 is 13.33 and 20. So using this technique and the previous one technique, so depends on whatever is available, how the equation is available, you use accordingly and you can solve this equation, right? So let us go for another equation, another problem solving, little bit of difficult than this, but it is tricky and it can be easily solved also. Let us find out this. Let us take this first, the nodes. Let us take 1, 2 and 3. Let us say this is a node 1 with potential V1, node 2 with potential V2, and node 3 with potential V3. So like another node is over here, and let us say this is a reference node. Okay. So now we will try to write the equation for node 1. So we will write the equation for node 1 using KCL and Ohm's law. So you can write in detail using KCL and Ohm's law equation for node 1. So node 1 you have here. So let us take, let me elaborate this question also. In this question you can see that there is a term called Ix. Here and there is a dependent source to Ix, so don't be worried about. So right now this is a current source, it's a dependent current source. Ix is there. So actually what is this Ix? We will come to the node 1 equation just a while. What is Ix? Ix from this equation it's very clear, and see that it is nothing but V1 minus V2 by 2. This is what the value of Ix. Ix value is this. So Ix value we know like this. So this value, instead of writing 2Ix, we can also write 2Ix is equals to V1 minus V2 by 2 into 2. So that is nearly equals to V1 minus V2. So we can write this as a current source. But remember, this is a current source and this value is a V1 minus V2. We can write like this. V1 minus V2 is the current over here. So that is the only difference, otherwise there is no other differences available. So let us write for equation for node 1. So if I write for equation for node 1, just see that how many currents are going out, how many branches are connected, 1, 2 and 3. So you need to have 3 addition is must. So now you understand, you have a 3 addition done. So from node 1, write down that V1, so 1 is current is, let us say this is 1, this is 2 and this is 3. So 1 is 1 minus 2, V1 minus V2 divided by 2. V1 minus V2 divided by 2, that is the current which is going in 1. Current which is going into is V1, how it is going? V1 it is going to 3. So why not we will write V1 minus V3 divided by 4. From 1, again the third current which is coming out of it, but yeah, good thing is that 3 ampere is already known here, and this 3 ampere is going to 1. So because this 3 ampere is going to 1, so we will have a minus of 3 is equal to 0. So in this way we can have first equation done. So how to solve it? So V1, you just take the coefficient of V1, 1 by 2, here 1 by 4, then coefficient of V2, it is a negative, so V2 1 by 2, then V3 1 by 4, 3 is a constant, so take the 3 out, so 3 is here. So one thing is, you can observe that when I am writing for equation for node 1, so only the V1 term is positive and V2 and V3 terms are negative. So this is one, you can see that there is a difference that we find here, and now we can solve this. So you can solve this by, like, this is 3 by 4 V1 minus V2 by 2 minus V3 by 4. So here is equal to 3. Just multiply here 2 and multiply 2 on the top, so that the denominator will be common, and then we can write this as 3V1 minus 2V2 minus V3 is equals to 3 4 12. So this is what is done. The first equation is done like this. So I think this is the first equation done for the node equation 1, right? Let us go for the equation for node 2. So equation for node 2, let us take this as try to write the equation. So how many branches are connected with it? So we have got 1, we have got 2, we have got 3. So 3 branches are connected. We are assuming again that all the current is going out of the node 2. With this assumption, so we need not to worry about the sign now. We say always V2 is at higher potential. So we'll write V2. Same thing you can write applying KCL and Ohm's law. So we write V2 minus V3, V2 minus V3 divided by 8. This is which is going from 2 to 3. Which is going from, like, reference is over here, which is going from 2 to the reference. So V2 minus 0. Need not to write V2 minus 0, rather simply V2 by, which is the resistance is 4. Again we can write from V2 to V1. That's how we can write V2 minus V1 divided by 2 is equals to 0. There is no like current source over here, so we will not get a constant term. So obviously from here we just need to take out the coefficients. So what are the coefficients of V2? 1 by 8, 1 by 4 and 1 by 2. These are the coefficients of V2. V1 is obviously negative because we are talking about the node 2. The coefficient of V1 is, so minus of V1 divided by 2, and here V3 minus of V3 divided by 8 is equals to 0. So we can make a solution out of it. We can say that this is nothing but 7 V2 by 8, taking the LCM, 7 V2 minus V1 by 2 and minus V3 by 8 is equal to 0. So multiply 4 on the side. So the denominator is now common, so we can rewrite this. But first you write the V1 coefficient so that we can have a sequence. So minus of 4V1, this first. Then you have 7V2. And then you have minus V3 is equals to 0. So 8 denominator, 8 into 0 is 0, so that is not required. So we have got second equation done for node 2. Like that, we can also write for the node 3. So equation for node 3, let us see that in node 3 you have got how many branches are connected? 1, 2 and 3. So you have got 3 summation of currents will be 3 sum of the currents. So for 1, the good thing is that the current source is there and the value is 2ix. So let it be 2ix, the current source, and the value of in I2 it is V3 we are talking about. So we will write V3 minus V2. Here also we have a reference, and V3 minus V2 by 8. And then we have another one, V3 minus V1. So V3 minus V1 divided by 4 is equal to 0. So Ix value, 2Ix value we have already solved it. It is coming around how much? V1 minus V2. So substitute here V1 minus V2 plus V3 minus V2 by 8 plus V3 minus V1 by 4 is equal to 0. Take out the coefficient of V1 here. So if I take out the coefficient of V1, see that 1 and here minus 1 by 4. So this and this minus 1 by 4 and 1. Another is take out the coefficient of V2. Oh, this is minus 1 and this is minus 1 by 8. And then take out the coefficient of V3, 1 by 8, and this side is 1 by 4, and that is equals to 0. So if our equation is ready, and just we need to solve it out, and to solve this becomes 3 by 4 V1, this becomes minus 9 by 8 V2, and this side becomes 3 by 8 V3 is equals to 0. Try to equalize the denominator, so multiply 2 here, this will be 6. So we can write down that 6V1 minus 9V2 plus 3V3 is equals to 0. So now we have got this another equation done. So right now we have got 3 equations for node 1, node 2 and node 3, and these 3 equations we have done like this in a single this way is we need to now solve these equations. So let us say this is equation 1 and 3, 1, 2, 3, so we need to solve it. So we can use an ordinary method to solve the equations. Let us try both the methods, the ordinary method and the Kummar's rule, to solve the methods. So if we take a ordinary method first, which two I should choose, and so that I can see that V3 here is having a common. So if I subtract 2 and 3, so from subtracting, so you can write subtracting equation 3 from equation 2. Equation 3 from equation 2 you can do directly, or let me write it properly first. V1 plus 7V2 minus V3 is equal to 0. Then you have got 3V1 minus 2V2 minus V3 is equal to 12. You need to subtract it, so the plus is already there, so just change the sign here, and minus here, plus here, plus, it will be minus. So it will be minus 7V1, and here it is 9V2 is equal to minus 12. So you get equation 4 after subtracting. So another thing you can do is that if you can add equation 1 and 2. So if you have add equation 1 and plus and 2, equation 2 multiplied with, so you can just write like this, instead of writing add, you can write equation 1 plus equation 2 into 3. So if you get this type of, this is done, so what you will get exactly, so 6V1 minus 9V2 plus 3V3 is equal to 0, and this side will multiply with 3, so this will be equals to minus 4 into 3, that is minus 12V1 minus, we are multiplying 3, so sign will not be changed, so this will be 7, 3, 21 V2, and then this is minus 3 V3 is equal to 0. So finally what we're going to get from these two is that here we get minus 6 V1, and here these two will cancel out, and here also we are going to get 9 is cut, so it will be 12, so plus 12 V2 is equal to 0. So what is the advantage? We are getting only V1 and V2, and here it seems that V1 is equals to 6 V1 is equal to 12 V2, and we can easily write V1 is equal to 2 V2. You can see that how much we're using a trick. We are trying to solve it in an easy way, but it takes a long time to solve these equations. So we get a value of V1 and V2, so substitute the value of V1 in this equation. So I'm just writing this, let us say equation 5. So from, you can write from equation 5, substituting the value of V1 in equation 4, you have got minus 7 into 2V2. So you can see that minus 7 into 2V2 plus 9 into V2 is equal to minus 12, and solving that you can find V2 is equals to 12 by 5 which is equals to 2.4, and from that we can find V1 is equal to 4.8, and obviously by putting the value of V1, V2 in any one of the equation, you can get V3 is equals to minus 2.4 volts. So this is how you get the answer of V1, V2 and V3 by solving this equation. Now this equation can easily be solved if you use a Kummer's rule and try to solve in a easier way, or if you have a calculator where you can have 3 variables you can put, so that way also you can solve. So let me try to write down this equation in a matrix form. So see how easily it can be written in the matrix form. Just I am writing the coefficients. And first you have to write down the things in a like V1, V2, V3 in the same sequence you have to write. Then you have to write the coefficients, then you have to write down the variables V1, V2 and V3, and then you have to write the constants, that is 0, 0 and 12. Okay, so this is what you can write in the matrix form, and then you can do the inverse of this matrix. So you can find out the inverse of A matrix. AX is equal to C, so X is equal to A inverse C. So you need to find out the inverse of this A matrix. So if you find the inverse of A matrix, then you find the value of V1, V2 and V3. It will also come out to be 48, 4.8 and 2.4 and minus 2.4. So you get the same answer by solving it in the Kummer's rule. But see, V1 is 4.8, V2 is 2.4, V3 is minus 2.4. So in this way you can solve this. So if somebody is asking now what is the value of Ix in this equation, so it is now very easy. So Ix is what? Ix is nothing but V1 minus V2 by 2. And since you know the value of V1 is 4.8 minus of 2.4 divided by 2. So you can also get this much of amperes. You can find 2.4 by 2, that is 1.2 amperes. So now you can find the value of Ix. So once you know the value of these nodes, voltage V1, V2 and V3, obviously you can find the current from any. Suppose somebody is asking the current from 4 ohm in this direction. Okay, V1 minus V3 divided by 4. But somebody in the question it is asking that what is the current in this direction. So okay, V3 minus V1 divided by 4. So node analysis means finding the potential of the node. So in a network you need to find how many nodes are possible, get to the minimum number of node, and the node which is connected with the maximum number of branches, make it a reference. You can in the book, for confusion, they can also give like instead of writing that this is a, they can say this 2 is the reference one, this 2 is a reference one, they can make it this as a 2. In that case you can take it as an exercise and you can solve it. Like if this is a reference, then how you are going to solve it? Simple, you have just node, if this is a node 2, the node 2 equation will change, equation of node 2 will change, that you can see that equation of node 2. So instead of having the equation of node 2 like this, so there will have another equation of node 2, and also it will not only change the equation of node 2, it will change the equation of node 3 and node 1, because now they are all interdependent. So once you change the value nodes and the reference node, once you change the reference node, other things will also change, but the answers will be same, like not the potential. Answer is what is the current through 8 ohm, that answer will remain same whichever you are choosing as a reference node or whichever node you are calculating. So that's all for the node analysis. In the next video we'll go for the mesh analysis and understanding the concept of mesh analysis. Thank you very much.